Alright, what's up guys? So in this tutorial, well actually just a recap, in the last tutorial we were looking at the motherboard. As you can see here is a motherboard. So now we're going to move on to the CPU. The CPU. Okay, so the CPU is also known as the brain of the computer. So basically without the CPU the computer is a dunce. Basically it's just a lot of electronic components that don't really do much unless you have the CPU. The CPU just controls the whole computer basically, and CPU stands for Central Processing Unit. So it's also referred to as the processor. Um, so what the CPU does, just say you have a program you want to run on your computer, whether it's a program to do with the head that's controlling the hardware of your computer, or a program like an application. Your CPU executes that program. Your CPU makes it happen. And what a program is, just a little definition: a program is a sequence of stored instructions. Essentially, a CPU does basically. As far as I'm aware, there's two major CPU architectures. Basically, there's two major CPU makes, if you know what I mean, like CPU architectures, two main CPU makes that you'll find, two main types of CPU that you'll find, and the architectures as they're known as, the two major architectures, CPU architectures, related to instruction sets. This, to be honest, if you don't understand this instruction set bit, I wouldn't be too worried about it, because I don't really understand it myself. But just to let you know about it, there's two major architectures related to instruction sets, and that is reduced instruction set computer, or RISC. Basically just a less, let's say, clever or complex version. And then the complex instruction set computer, or CISC, basically the smarter one. Anyway, don't worry too much about that, but if you ever see this again, at least you'll be, you won't be totally new to it. So that's just to let you know about that. And then the hyperthreading. I want to tell you about hyperthreading. What hyperthreading is, it's basically something that is like a technique that's it's like something that's modified. The CPU's modified, or it's just like it's basically just enhances the performance of the CPU. Hyperthreading, if you ever hear of hyperthreading a CPU, or a CPU hyperthreading, it's just something that enhances the CPU's performance. Basically, that's what hyperthreading is. And now, okay, so one time depends on, so the processor data bus. So basically, the channel coming through the motherboard up to the processor, where the electricity, which is of course electricity to a computer, will be data. So the data bus is so processor data bus is basically what's connecting the processor pretty much to the motherboard and to the other and all the data. Like, I told you program, like the CPU runs the programs. Well, basically the programs get to the CPU through the data bus. The data gets to the CPU through the data bus, and the size of the data bus, like the bigger the data bus, the more amount of data a CPU can process at the one time. So The amount of data that a CPU can process at the one time depends on the size of the processor data bus. So the bigger the data bus, the bigger amount of data it can process at the one time. So basically, the bigger the data bus, the better. And overclocking, basically overclocking is basically modifying your CPU to make it work faster, than it's specified to work. This is all handy dandy. It makes your CPU work faster, but it also it wears it out too, like. Alright, so that's overclocking. And now onto the last bit about CPUs. Basically, you have like the core of the CPU, which is like, the brain of the CPU. The main part of the CPU is the core of the CPU. And obviously old school CPUs have just the one core. But now the manufacturers, there's two main manufacturers of CPUs that I know of, and most people know of. Intel, I'm sure everyone's heard of Intel before. They're a major player in manufacturing CPUs, and also AMD is another company that are a major player in manufacturing CPUs. Both of them are just as good as each other, I think. Everyone has their own preferences, of course, but they're the two major players I know of for CPUs. And basically, the manufacturers of CPUs have found ways, well, a long time ago, have found ways of putting more than one core on a single CPU chip. So basically, you have your CPU and it's got more than one core on it. So I'm sure everyone's heard of, dual core CPUs and triple core CPUs. Intel dual core or whatever, dual core processor or whatever. So basically, a dual core is just two cores on the single chip. Triple core is three cores on the single chip. Quad core is four cores on the single chip. So quad core, as you can imagine, is a hefty one, like, and I'm pretty sure it goes even higher than quad core. I'm not too sure. I know for definite that we have the quad core, but I'm sure there's more. They fit plenty more cores on it, maybe even double a quad core. I don't know, but basically, just to let you know that there is, whenever you hear dual core or quad core processor, basically just means that there's more than dual cores. That means there's two cores on the single chip, basically. So now onto some pictures. What does a CPU look like? And that's what a CPU, that's the underneath of the CPU, that's the top of the CPU. I just kind of realized for the next tutorials I'm actually going to start putting the pictures at the start. Alright, so for this tutorial I'm just going to finish it up with the picture at the end. Alright, so basically, if you have a CPU, this is what it looks like on top. As you can see, it's an AMD CPU. You can just go on to I recommend just going to Google Images and just doing what I did and just Google image, whatever you want, like CPU, motherboard, and you'll get tons of images. And that's where I got these, just Google image, like, and you just get some great pictures just to have a look at them and see what they look like. So basically, when you see a CPU, this is obviously not real size. It's only about the size of like a CPU is, but the size of your, I don't know, like baby finger. They're small enough, like pretty flat. So that's what the top is like. And in the underneath, you have tons of these pins. You see these gold pins, and they slot into your motherboard. And the socket for the CPUs, I'll show you here if I can write it. The socket for the CPU, right? There's a technology on the socket. It's called ZIF. That's too small. Let me make this bigger. ZIF, right? You see this here? ZIF. And what that means is zero insertion force. And most CPU sockets are, ZIF sockets, so zero insertion force, which means the CPU just drops in. You don't have to like push it in or anything like that, it just drops in, because these pins here are so delicate and they can bend so easily. So when you're handling a CPU, don't touch the pins and be so careful when you're putting it back into the socket, and just remember that it should just fall in itself with ZIF, because if they bend, your CPU is screwed basically. Alright, so that's CPU.